that
Sorry about that. Hey, Andy, we're looking at your desktop right now.
Okay, so should I hit got it? I think I can hit got it there. Okay. Uh-oh, now what happened? All right. And then with this, I'm gonna focus some more more effort on drilling down a little bit and talk about red alder and its role in the aquatic or riparian systems, because I know that these riparian systems are something that your watershed council really likes to focus on, and that's and so I thought I'd spend a little bit of time talking about that. And then finally, some just wrap up and some questions if any haven't been answered. But like Zach said, I'm free and willing to take any questions while we go. And hopefully, Zach, like he said, will pay attention to the chat and we can answer any questions that come up.
Sounds good to me.
Okay.
We're still seeing your desktop and not the presentation, by the way.
Oh.
Do you have two screens, maybe?
I do.
Ah.
I do. How's that?
Nope. Still your desktop. There we go.
How's that? Okay.
Perfect.
All right. Sorry about that.
Hey, no worries.
All right. So yeah, so that's basically what I'll do, and we'll, now that you can see my slideshow, I'll get started here. If I can. There we go. So when we look at the Pacific Northwest in general, and not just in the Coast Range, but the general Pacific Northwest, you can see that 87% or so of the growing stock here is softwoods or conifers, and only 12% are hardwoods. So hardwoods make up a very small percentage of the total landscape, forested landscape out here in the Pacific Northwest. So really conifer is king out here, both traditionally, like pre-European settlement and post-European settlement. The people have gone through the pollen records and have basically shown that the number of hardwoods on a per acre basis hovers around this 10 to 15% historically and currently as well. So that's what we're looking at here. It's not a huge percentage of the growing stock. And then of this growing stock, say of that 12%, red alder makes up about 61% or so of the hardwoods out there. So it is a big component of the small component. The next major species are big leaf maple, and then a scattering of madrone and cottonwood and oak. And then there are some other species such as birch and cherry and a few other things here. But, you know, in a lot of regards, red alder is the dominant hardwood species in the Pacific Northwest. And this just shows some of the range map on the left. It grows all the way up from Southeast Alaska, all the way down to, you know, northern type of central California here. And it's always where it's wet. It doesn't grow on the east side, and it likes it where it's wet. So the whole coast of British Columbia, Washington, Oregon, and then it gets narrower and narrower its range as it moves down into California. So it has a pretty wide range, and it's fairly common throughout its whole range here. Middle picture, I mean, and the right picture just shows the tree in general. Hopefully everybody knows what red alder looks like. It's not always the case though. When I talk to people from the Midwest or back east, they always think of red alder as just being a shrub or a little bush. And they don't really know that alder can grow to tree size and become, have its own forest type. So just wanted to throw that out there and let you know what red alder looks like and what its range is. And with that, the silvix basically means its characteristics. And so, like I said, it's actually a real tree. It can get to 120 feet tall. It can get to 2 to 3 feet in diameter. Not as big as many of the conifers out here, obviously, but still a large and merchantable tree. Unlike all the other conifers, it's a very short-lived species. These stands really mature in 60 to 70 years old, and most of alder will not live past 100 to 120 years old. If you could find a 120-year-old alder, that would be a really, really old tree. So it has a very short-lived lifespan. The other interesting thing and very important in regards to alder is that it's very intolerant of shade. For alder to regenerate, it needs pure sun, open sun. So you won't really find alder growing up underneath other trees or bushes or anything like that. It's pretty sensitive to heat and to drought. So that's why we find it on the Oregon coast mostly, and up to maybe 3,000 feet in the Cascade Range. It doesn't like it very cold. It's pretty frost sensitive. It can tolerate some flooding, but it doesn't really like swamps and poor drainage. So that's where you typically find alder. And like I say, it's an early successional species. It usually regenerates from seed on disturbed soils after some type of disturbance. Alder can sprout as well, but they need to be very young, and it's not a very reliable form of reproduction. Almost all alder reproduction is from seed. Alder fixes nitrogen, which I will get to in a bit here, but that's one of the key aspects of alder, and one of its major roles that it plays in the ecosystem. Like I said, it is a commercial species, and it has its price goes up and down throughout, with time, like all wood prices do. But it's not a commodity. You don't make 2x4s out of it. It's usually made into, if it's not pulp or pallets, which are the low grade alder, it's often made into furniture and cabinets, and real nice alder is peeled into veneer to make really high quality plywood. So alder has been a component of the timber industry and the economy of the Pacific Northwest for a very long time. But it's the amount of volume cut compared to Douglas fir is very small. But there are some mills around. I'm sure you're aware of the mill in Garibaldi there, and that's probably one of the closest mills you have to the Nehalem area. So those are some of the products that are made from red alder. To go into a little bit about the alder distribution, like I mentioned before, a lot of people think alder grows in swamps, but that's not really the case. A lot of very flood-prone areas are either cottonwood or ash. Alder can handle a little bit of flooding, but it doesn't like standing water for long periods of time. So that's one common misconception about red alder. Alder, however, loves growing along creeks and rivers. You can find it lining the banks of really large rivers. I think this is the Quinault River up in the Olympic Peninsula here. You commonly find it along these perennial streams and creeks. It's very common growing in those areas. You also find it in these seasonal or intermittent creeks, these small type 0 or 0 order creeks higher up into the uplands. And then finally, alder does actually grow very well in an upland environment. Historically, a lot of alder was found up here in these uplands. But in today's day and age, a lot of management practices have discouraged alder on the uplands. And I'll get to that in a minute here. So alder can grow in a lot of places, but doesn't have a huge ecological amplitude like Douglas fir does. Douglas fir is, sea level to 5,000 feet and all the way into the Rocky Mountains and way down into Mexico. So alder can grow in a few places around the Pacific Northwest, but not every place.
We've got a couple questions in the chat here.
Yeah, sure.
The first one is maybe a question comment. Why is it a hardwood grows like a weed?
Why is it a hardwood grows like a weed? Okay. The hardwood softwood terminology is often very confusing. Alder has harder wood than, say, grand fir, even though alder's a hardwood and grand fir is a softwood. So the hardwood softwood thing is kind of confusing, and typically trees with leaves are called hardwoods and trees with needles are called softwoods. And oftentimes the density of the wood correlates with that. In general, oaks and cherries and walnuts and things that we consider hardwoods actually do have hardwood. And some conifer species that we consider softwoods actually do have softwood, but it's not 100%. So that's a little confusing. Hopefully that'll clear a little bit up. It's just historical reasons from European forestry that we get these terms hardwood and softwood. And why grows like a weed? Yeah, so the thing with alder is it is an early successional species. So it colonizes areas that have been disturbed. And it seems like it developed a strategy of existing by live fast, die young. Some species of trees have that strategy. Eucalyptus, I don't know, I'm trying to think of some non-tree species, I guess. Some species, oftentimes growth rate is correlated with maximum longevity in terms of lifespan. So it just seems like alder has one of those species that has that, like I said, that live fast, die young type of growth strategy. A lot of other species don't, like cedar. Cedar grows slow and lives long. So that's just kind of how it's adapted and how it behaves as a species.
The next question is, are alder stands connected by mycelium?
Okay, so yeah, that's a good question. That's an interesting question. You might be the person with this question is probably referring to some of the work that's been done in a lot of the Douglas fir and other conifers out there by what's her name up in British Columbia. But the Wood Wide Web and how these trees and forests are all connected to one another, and there's parent trees and they share resources and things like that. So I think that's what this question is getting at. The mycelium are the underground bodies of fungus. And there hasn't been much work with red alder in terms of its fungal hosts or its interaction with other tree species. We do know that birch and Douglas fir can connect with the mycelium network, but not much has been done looking at alder. Alder does have host-specific mycelium, like almost all trees do, that help it gather water and nutrients in exchange for sugar. But it's, like I said, there hasn't been much research into how it fits into this quote, wood wide web that has been discovered and made it into the common knowledge recently. So hopefully that answers your questions there. So, okay, so with that, I guess I'll keep going. Keep adding questions into the chat if you need any more clarification on that. So, like I said, alder can grow in a lot of places, but it doesn't grow well in a lot of places. This is just like a GIS map made by Washington DNR. The dark green shows where alder site productivity is high. The light green and tannish shows where alder doesn't really grow well at all. And so what makes an alder site productive or not, in terms of production, meaning fast growth rates and large tree sizes, is kind of the same factors that affect all type of plant growth. It's the elevation, precipitation, soils, drainage, aspect, and topographic position. Just briefly, elevation, alder grows basically best below 1,000 feet. It can grow higher in elevation than that, but the growing seasons are shorter and the temperatures are colder, so it doesn't grow that well. Alder likes a lot of precip. Oregon Coast Range is perfect for it. The Willamette Valley is a little bit too dry for it. Soils, alder is not that picky in terms of soils. Some soils are better than other soils. The Coast Range sandstones are better than, say, the Coast Range basalts. But I'll get into why soils aren't that huge of a factor when it comes to alder. I'll do that in a few minutes here. Drainage, alder likes well-drained soils, but not droughty soils. Aspect, alder doesn't like a lot of heat, so south-facing slopes get a large heat load in the summertime, and that really kind of slows alder growth down. Alder like north slopes or flat aspects. Topographic position, where alder grows on the hill between the ridge top and the creek bottom is probably one of the most interesting factors in terms of alder productivity. I've seen alder units that have been planted going from a ridge top all the way down to the creek bottom, and the alders in the creek bottoms are usually so much bigger and taller than up on the ridge. And I think a lot of that has to do with, once again, drainage and exposure to the elements and wind and things like that. So yeah, topographic position is a big indicator of alder productivity. So that's kind of how alder grows and where it grows. Now I'd like to switch a little bit and talk about its current state. and what its future might be. So, will alder be around for a while? What's affecting the red alder future? The supply in the future? So the first thing to notice is that the Douglas fir boom busted red alder. There was historically a lot more alder on the landscape than there is currently. Many of the alder stands that existed in the Pacific Northwest were either deemed worthless and just herbicided and converted to conifer. That was a common practice back in the 60s, 70s, and into the 80s. But when alder prices went up in the 80s, those alder stands were cut and sent to the mill for the landowners to make money, but they were very rarely replanted or let alder come back. So there's been a lot of conversion of alder stands into Douglas fir stands. And that has really had an impact on the prevalence and presence of alder on the landscape. This is a graph that kind of just shows what has been happening over the last 30, 40, 50 years. You can see that hardwoods in general and alder specifically, the percentage of the total inventory in Western Oregon and Western Washington has declined. You can see that it's a common trend. I don't have the numbers for the 2020s yet, so we don't know if it's going to keep dropping below 9.4% or not. But this is a clear indication that the future supply of alder across the landscape is declining, and I would say fairly significantly too. A question that arises with this declining amount of alder on the landscape is, will there be enough of it to support a viable alder timber industry? That's a question that is unresolved at the moment. Like I said, a site like this where you have, half of a hillside, half of a mountain covered in red alder is a very rare site today indeed. Oftentimes after fires and things, alder would move in and occupy upland areas like this. And these are pretty rare nowadays because the common management objective is to have Douglas fir there, not red alder. But you still see a lot of alder in the landscape along roads, anywhere where there's a disturbed area. I'm sure you see it living up on the Oregon Coast Range there, that oftentimes the only alder you see are along the roads where there's a bunch of sunlight and where there was some type of disturbance that created a seed bed for the alder to germinate on and grow. So you see a lot of like stringy distribution of alder along the roads. And lastly, the most prevalent place you find alder now on the landscape are along creeks. And these are in the riparian management zones, or what we often call the riparian buffer. And that is basically the result of two things. One is that these creeks and rivers often have flood events that scour away vegetation and create a bare mineral seed bed that alder can grow on. And the second reason why alder is often there is because the industry or state agencies can't harvest alder from there. So that's often why you find alder in these riparian zones. So that's some aspects about supply. Another thing about alder is, and the picture in the upper left of this slide here kind of shows often what you can see in alders. Alders sometimes, it's not really common on industrial land. The majority of the alder resource is on small private timberland owners. or non-industrial private foresters, as a common term used for that. And that's because oftentimes these were old farms, these were old fields. There's a lot of reasons why there's, these little patches of alder on these acreages here. And there is some concern that with urban sprawl and with increasing development, that a lot of these small farms will be turned into subdivisions, housing, areas where people live, and we might lose a lot of alder on the landscape due to urban development, especially in Washington. Oregon has pretty good rules regarding the protection of forest lands and farmlands, but oftentimes Washington doesn't have that. So that's an issue in terms of the red alder supply in the future. The climate, we can't really ignore climate and climate change when it comes to these forests. And this is a picture of an alder stand that burned during the Lions Gate fire out of Salem a couple years ago. If the climate heats up and we get more and more fires, one would think that that might increase the red alder prevalence on the landscape, because alder is very adapted to coming in after fire. So if fires increase in both intensity and in extent, we might see a larger, alder increase on the landscape. On the flip side of that, of global warming, is that when we see heat and drought events like we've been seeing lately, the last few years being the hottest on record in Portland, and that heat dome event that happened a couple years ago, alder is very sensitive to heat and drought. This is a picture I took up in the Skagit Valley area in northern Washington, and this is God's country for red alder. But this stand specifically, I think, is dying because, and it's just falling apart. And I think, I can't prove it, but I think it's because of the heat and the drought that area has been experiencing lately. And with heat and drought and a changing climate also will affect the prevalence and distribution and numbers of insects and diseases. In general, alder is pretty resistant to many diseases. The picture on the left shows some alder bark beetle holes. The picture on the right shows some cankers caused by nectaria. Those are the two more common diseases and insects that can kill alder and alder stands. But, like with the emerald ash borer now being discovered here in the Pacific Northwest, we can't rule out any type of outbreak from either native pathogen or insect that changes with a changing climate, or an exotic or introduced insect or disease that could possibly affect red alder. So that's always an unknown, but it's one that we should definitely consider when we talk about and think about alder's distribution and future supply. So there is, that's just kind of the who, what, where, why, and when of red alder. And let me check the chat here. Looks like there's no other questions in the chat. So I'll move on to the next area that I want to focus more on, and that's the ecological importance of red alder. And specifically, I'm going to focus on the Coast Range. Like this picture was taken up near Cascade Head on the Salmon River estuary, which is right down from you guys here. Alder plays an important role in the Pacific Northwest, and one of its main contributions or effects in the ecology of the region is that it fixes nitrogen. all plants need nitrogen, and nitrogen is the most commonly limited nutrient for plant growth. And it really affects tree growth, soil fertility, and carbon storage in forests worldwide. Most plants take nitrogen that gets weathered from the soil, that gets weathered from the rocks and into the soil. However, there are a few species worldwide that can actually pull nitrogen out of the air and convert it into forms that are available to plants. And red alder is one of those. The picture on the right shows an alder root and all those little orange ball type things. Those are the organism. It's called Frankia. Frankia is the genus. That's the organism that lives symbiotically with red alder and actually fixes nitrogen, converts atmospheric nitrogen into usable form. In exchange, the alder gives it sugars and other byproducts of photosynthesis that the Frankia can't produce on its own. So it's like the mycelium. How much nitrogen is added to the soils? The rates range depending on what study you look at, the age of the stand, the soil type, things like that. But it's oftentimes 100 to 200 pounds per acre per year, which is a lot of nitrogen. And in fact, when it comes to fixing nitrogen, alder fixes more nitrogen than it needs. So there's a lot of leakage in the system. And all that nitrogen that leaks out gives the Oregon Coast Range the fertility and the high soil nitrogen levels that we observe. We know that the soils themselves, through weathering, produce nitrogen. But with isotope analysis, scientists now can figure out by looking at like I said, the isotopes of nitrogen, if the nitrogen comes from rocks or if it comes from the air. And about 90% of the nitrogen in the Oregon Coast Range comes from the air, meaning that it came from alder. So over the millennia, over the thousands of years that alder stands have occupied areas across the landscape, that is the reason why the Coast Range can grow such vast and big trees. It's all because, not all, but a large component is because alder has created these real nice fertile soils through its nitrogen fixation. So that's a pretty rare thing. Some acacias do it in Africa, and there's not that many other species out there that that convert nitrogen at the rates that red alder does here in the Pacific Northwest.
Hey, Andy, I got
Yeah.
in the chat here. The question is, I have a 10-acre stand of alder that is 35 years old and don't plan to harvest it, but leave it there to let nature do its thing. Is that a good strategy for the health of the stand?
That's kind of a tricky question. The health of the stand. So if you don't plan to harvest it and just leave it alone, alder in probably another 35 to 50 years, those alder will die and that stand will disappear. So whether that's a good thing or a bad thing, I guess it kind of depends on your objectives as a landowner. It is the natural thing. That's what alder will do. So if you do nothing, the alder will eventually disappear and probably, I'm not sure about your acreage, but probably be replaced by other conifers, or if it's near some disturbed land, maybe like a whole bunch of salmonberry or Himalayan blackberry or grass or something, like if it's an old farm field. that might happen. If you want an alder stand, you would need to create conditions that will allow it to regenerate. So you'd oftentimes clear cutting will result in alder coming back. If you tried to plant alder underneath alder, there wouldn't be enough light for those alder seedlings to live. So it's just the way the alder life cycle works. It comes and goes, and it comes and goes pretty quick in terms of a time scale. Maybe not a human time scale, but an ecological time scale. So yeah, I mean, animals the stand will keep providing ecosystem services for its life, and it is kind of a natural thing for alder to just kind of slowly get replaced by conifers. But I can't really say whether that's a good thing or a bad thing, just the way it is. So with that, I guess I'll just keep rolling here. Another thing about alder, and it's not really a trait in and of itself, but one thing about having alder on the landscape and its role, its ecological importance, is that alder is resistant to a lot of diseases that conifers get. So if you're, let's say, like with Swiss needlecast, it was Swiss needlecast, I'm sure you're all aware of it. It was it's a native disease, but it really came to prominence in the 1990s. And it's really affecting Douglas fir right along the coast of both Oregon and Washington, but especially in Oregon. The amount of how much Swiss needlecast covers across the landscape varies from year to year, but give or take, it's about 500,000 acres. And what it does is it plugs the stomates of the older needles on the Douglas fir. Healthy Douglas fir have 4, 5, 6 years worth of needles on the trees, but trees with severe needlecast will only have 1 or 2 years worth of needles. The youngest needles. So therefore its photosynthesis rates decline, and therefore its growth rates decline. And in some areas where that's hit really bad, which, the Tillamook is the center of the Swiss needlecast. That's like the crater, the bomb zone of it. You can get 50% volume losses. So that's caused a lot of landowners to switch to other species like hemlock. Hemlock's not susceptible to Swiss needlecast, and either is alder. So alder's important in that regard, that it could be an alternative species in these areas that are hit by Swiss needlecast. Likewise, it's not susceptible to laminated root rot. Laminated root rot is, once again, that's an endemic disease that's been here forever. That's more scattered across the whole Pacific Northwest, but some estimates say about 10% of the forest in the Pacific Northwest is affected by root rot. And it causes a lot of growth losses to Douglas fir and other conifers as well. And the thing is that it persists in the soil. So even if you cut a stand of trees that has laminated root rot, if you replant it, or even natural seedlings that come in will get infected by it, because it still lives in the soil, and it can live in the soil for almost as long as 50 years, 50 to 100 years. People don't really know for sure. So one solution that people may want to try to adopt is, if you wanted to reduce the laminated root rot across the landscape, is you cut the infected conifer stand. You could plant one rotation of alder, and during the time that alder is growing, the laminated root rot will disappear from the soil, and then therefore, if you put conifers back into that acreage, they would be free from laminated root rot. So that's another disease that is common in the Pacific Northwest that is alders not affected by. Another insect that causes some problems, especially along the Oregon coast, is the spruce tip weevil. I'm sure living out there, you guys have all seen these Sitka spruce with these dead tops. It's a weevil, it's an insect that bores into the terminal, the leader of Sitka spruce, and kills it. It generally won't kill the tree, but it really slows down the volume growth and the appearance of the tree. They often turn into bushes. But this graph on the right shows some preliminary research that was done looking at the amount of weevil damage, which is on the y-axis here, plotted against how much alder is above the spruce. And you can see that spruce grown underneath alder has less weevil incidence than spruce growing out in the open. So that seems kind of to be another role that red alder can play in the fact that it can help even mitigate or reduce some diseases that affect other species. So disease resistance is one major role that alder plays, and nitrogen fixation is another. I can get into a bunch of other things about how it provides a lot of other wildlife habitat and other ecological functions. But those two are the two ones most often looked at and considered. So let's see here. Before I move on, let me check the chat here. No, alder is has nothing to do with sudden oak death or that Port Orford root disease. What is that? That's I forget the Latin name of the root disease. No, alder is not a spreader or transmitter of either of those diseases, nor is it susceptible to that. It's completely independent of those diseases. So it doesn't hurt or help sudden oak death or that root rot disease. So with that, let's keep going here and touch on, like I said, alder develops after disturbance. The common disturbances were fire, wind, and flooding and landslides. Those were the pre-European kind of disturbances. Well, fire was always part of the landscape with indigenous burning. And now timber harvest. Alder really loves to come back in after clear cuts. It is an early successional pioneer species, like I mentioned before, and therefore, without repeated disturbances, these red alder stands are replaced by the longer-lived and more shade-tolerant conifers, which goes back to that question in the chat room. So oftentimes, after large-scale disturbances, the alder stands that develop at really high densities, and they grow really fast. And because of those characteristics, it's often very difficult for other tree species to get established underneath an alder canopy. And I'll touch on that in a minute here when we move into some of the roles alder plays along creeks here. So often underneath alder, you end up with really dense salmonberry, or in really disturbed systems, like maybe down in the Lower Nehalem and the dairy farms and stuff, you end up with a lot of Himalayan blackberry, or Zach, what was that? The ragweed? I can't remember that.
Pansy ragweed?
Yeah. So oftentimes you can develop the shrub layer, almost impenetrable shrub layer that will persist underneath these alder canopies. However, sometimes you can get alder will come back after a disturbance mixed in with conifers. Not much is understood about why or how or what conditions it takes to make that happen. Oftentimes, there's two common scenarios. One is that alder and Douglas fir come in together after a disturbance, and they kind of grow together, mixed together at the same time. But more commonly, when you see these mixed species stands, it's that the alder came in, and it came in at low enough densities where it allowed enough sun and there was enough rooting substrates available for either hemlock or cedar to germinate underneath. So you almost have a two-storied stand. You have the overstory of alder and the understory of these more shade tolerant conifers. So I mentioned that because that is important in understanding some of the roles alder plays in the ecosystem and in the riparian systems. Let's see here. Before I move on to that next section, let me look at the chat here. Any comment on myrtle wood as a hardwood? Myrtle is a fairly common hardwood down in the Southwest Oregon and Northern California. Myrtle wood is very well known for having super desirable wood properties and is very good for carving and making real nice specialty items. There's not a lot of it on the landscape, so therefore there are no real big myrtle mills. No one really plants myrtle. It's on the landscape, but at such kind of low frequency and with such a limited range that it's not considered, at least in the Oregon Coast Range or, in terms of the economy, a very important hardwood. It has a lot of function, just like alder does. All species on the landscape do perform functions. But I haven't studied myrtle wood much because I'm mostly in the Coast Range and Cascade Range. And so I don't have a whole lot to say about myrtle wood because it's a little bit outside of my wheelhouse here. But if you wanted to follow up with that chat with a more specific, if you had a more specific question, maybe I can answer that. So yeah, let's shift a little bit to some of the ecosystem services. Traditionally, forests in the Pacific Northwest were managed for one thing and one thing only, and that was wood volume. Now things are switching a little bit. There's a worldwide and a local interest in services other than wood volume, biodiversity, social benefits, ecological benefits, hydrological benefits, a lot of these other type of services that aren't generally were considered in traditional forestry. Some of the services and some of the goals that people are trying to promote currently are to increase the biodiversity of these forests and the structural complexity of these forests. People are interested in resiliency. A lot of these intensely managed plantations don't have a lot of resiliency. It's kind of the all your eggs in one basket kind of mentality. If you have all your eggs in one basket, things can happen, and oftentimes that is therefore not very resilient. People are really interested in improving wildlife and aquatic habitat. That's part of what the Lower Nehalem Watershed Council is all about. So I'll focus on that a bit here in a second. Other goals are aesthetics and sustainability and integrity of these communities. These are important goals and values that alder can be a component of. So those are some of the things that are currently now being looked at in addition to just the traditional forestry and creating board feet of timber. This gets at some of those goals and services that Alder can provide in riparian systems. This graph looks a little confusing, but it's not really. The y-axis is just the relative resource abundance. So how much of something, how much there is of something. And the x-axis is how much alder there is on the landscape. And if you look through these various lines, you see that when there's a lot of alder, there's a lot of alder wood in the streams. That's that line. When there's a lot of alder, there's a lot of vascular plant cover. There's a lot of aquatic invertebrates. There's a lot of stream nitrates. Songbirds increase with increasing alder. Bugs increase with increasing alder. Live tree basal area or volume decreases because alder can't support as many trees and as much biomass as the coniferous forests can. And according to this study, which was looked at in Southeast Alaska, fish density and total large wood in the headwater streams was unaffected by the percent of alder in these riparian systems. And that could be an artifact of, it's in Southeast Alaska, but I will talk about the large woody debris here in a minute. So you can just see that the role of alder affects plants, animals, bugs, fish, lots of things. So it does provide a lot of services in these riparian systems. Like I just mentioned, increasing red alder in the riparian systems usually has increased understory, increased herbaceous biomass, more light gets under there. It has more land invertebrates, has more aquatic invertebrates and songbirds. But if you increase alder, you usually have a decrease in the volume of standing timber and large woody debris. But in general, as contrasted with a pure Douglas fir stand, say, if you increase red alder in these riparian systems, you usually have an increase in biodiversity, obviously, because there's an extra species there, but there's an increase in biodiversity in other organisms as well, increase in structural complexity, improvement in wildlife habitat. You will have a decrease in wood volume, which is a concern to people trying to make money off of trees. And the question still remains how this affects carbon and carbon storage and carbon sequestration. Haven't been any real definitive studies yet to show how alder and riparian streams affects carbon sequestration. So let's get more about exactly where we are today in alder and its riparian systems. Historically, when during the logging boom back in the 20s, 30s, 40s, people weren't cared about ecosystem services. They were just wanted to get the wood out, and they would log entire mountains, they would log entire rivers, they would log across creeks. They didn't really value anything other than the amount of money they could make from the amount of wood they could get off the landscape. So they cut right across creeks and streams. We know now that that might not have been the best idea, but at the time, that's the way it was done. And it had a big effect on where we are today in terms of the forests and where we are today in terms of fish habitat as well. So many of these areas that were cut over with that first initial logging push came back into alder. And a lot of that alder is now found along the creeks and would be found in the uplands too. But like I mentioned, the upland alder has all been converted to Douglas fir. Not all of it, but a large percentage of it. And currently where we sit, up, for the last few decades, timber harvest and how it relates to streams has been regulated by the Oregon Forest Practices Act. And that act had a 20-foot, well, it still does, has a 20-foot no-touch zone where you can't touch any trees within 20 feet of the creek. And then from 20 feet to 100 feet out, depending on the stream size and whether it's deemed fish habitat or not, the rules are a little nuanced. Landowners are allowed to remove some of the trees, but they're required to leave a certain amount of volume in that 20 to 100 foot zone. So that's how the streams were treated under the Oregon Forest Practices Act. However, that's changed now. There's a new agreement with private and public land, and it's called the Oregon Private Forest Accord. And this has set new rules regarding harvest in relation to streams. And once again, there's a lot of different stream types that are classified. I won't get into those, but you can see that the riparian management area, the no-touch zone, is much greater under the Oregon Private Forest Accord than under the previous Forest Practices Act, up to 110 feet, really from 75 to 110 feet. So what's that's doing is it's quadrupling the no-touch zone along most streams in Oregon here. So this is a topic Zach and I were talking about a little bit, and I wanted to bring up to the group, and it's the role that how, where we are today with the rules we have, with the historical practices that occurred and the rules we currently have, how alder in these riparian systems is influencing the accumulation or lack thereof of large woody debris. Large woody debris is often a very major objective and component for determining the health of streams in regards to fish, especially salmon. So I thought I'd talk about that a bit here because I know this is near and dear to a lot of watershed councils, yours included in Oregon here. Where are we? Like I mentioned, these historical practices removed all the conifers and most of the large woody debris, not only from the uplands, but also from riparian systems. And this often this disturbance, this logging that occurred, often created these alder-dominated riparian forests that you can see today. Not every creek is dominated by alder, but alder dominates a lot of the forests along these Oregon Coast Range creeks. And these alder-dominated forests do not really provide large and long-lasting woody debris that is seen as crucial for fish habitat. So these alder aren't going to be dropping in these huge logs that is desired if we want to get the salmon numbers back up to historical numbers. In addition, these riparian forests often do not promote or even allow for conifer regeneration coming underneath. I touched on that earlier, and oftentimes it's alder with salmonberry underneath. So begs the question, is this a problem? Are we getting large woody debris in our streams? If we're not, should we? How do we? there's this is a fairly fairly big question that a lot of wildlife managers and watershed councils are looking at. So I don't have the real answers to that. There hasn't really been a lot of consensus out there on the land with scientists and professionals on this, but I'd just like to bring up a few considerations when trying to think about this problem or think about really this situation, because we don't really know the extent of this quote problem. It'd be nice to do these streamside surveys and do a lot of this work and figuring out how many of these creeks are alder dominated, how many have conifers, how much large wood is there, but we don't really have solid numbers. We don't know the extent of this. So some type of assessment would be a very good thing to do to find out just how widespread this condition is. And like I mentioned before, for the last 50 years, these creeks were really under the effect of the Oregon Forest Practices Act. And like I said, there was like a 20-foot no-touch zone and then a 100-foot partial cut zone. So oftentimes you'd have 20 feet of alder, and then outside of that 20 feet, you'd have a partial cut where they were able to take some conifers out and leave other conifers. Those conifers in that partial cut zone, in theory, could provide the inputs, 100, 200, 300, 400, 500 years from now, when these trees die of old age and fall over, if they were left there. But the problem with the Oregon Forest Practices Act is those that were left will probably likely be cut down the next time the landowners go in there to harvest the clear cut, and they just leave smaller trees in there again. So the Oregon Forest Practices Act didn't really have like a long-term vision for large woody debris inputs. However, that might change with this private forestry accords agreement that is just currently being implemented. There's a 100-foot no-touch zone. So that means any trees, no trees can be touched in there. And given enough time, there could be enough conifer growth where those become coniferous trees, and then those trees fall down into the creeks and provide the large woody debris that people think is required into these streams. Another consideration is how we can actually promote these large woody debris inputs. How we can do it, I don't know. I think of two ways. You either do a hands-on or a hands-off approach. Either approach, there's considerations to take. One is the cost. One is the regulations. Can we actually get into these systems and do these activities that we deem necessary or desirable? Another consideration is the accepted timeline. Will we let these large woody debris inputs happen over time? It might take 500 years. Do we have 500 years? I don't know. That's another consideration. And the other thing is, just a general philosophy. Should humans do this? Have we messed this up enough that our intervention is required? Or if we let nature do it, will nature kind of heal itself? Those are different philosophies and trains of thought that are considerations on this topic. So here's just another few considerations. Hands-on. I mean, currently, if we want, we can helicopter in root wads and large logs and dump them in the creeks. That is a hands-on approach, and it is done. I think most of us realize that the costs are unsustainable, and it's not really a long-term solution, but hey, it's an option. A hands-on-ish approach would be to encourage the reestablishment and the growth of conifers along these creeks. So they eventually would fall over and be present. This is often not allowed under the current forest practices rules, and is hard to implement because of regulatory red tape, but it is an approach that we can use. One of the methods would be to actually not touch the alder, but to plant conifer underneath the alder and allow the conifer to grow. Another would be to remove the alder or part of it, plant conifer, and therefore there'd be more sunlight and the conifer then would grow faster. That's another approach as well, but it's like I say, there's regulatory red tape involved with this. There are mechanisms in the Oregon Forest Practices Act and the Private Forest Accord that allow exceptions to these rules. So it is possible and it is feasible. It's just, it's a lot of work. And then finally, the last step is just the hands-off approach. Let nature take its course. We can also trust that the private forestry accords, that it would be a solution that would actually encourage eventual large woody debris inputs. And part of one thing that I am thinking about is we can use red alder's lifespan traits as a means to get more inputs into large woody debris. Like I said, alder lives like to 80 to 100 years old. A lot of the logging that occurred and a lot of these alder stands and these riparian systems were established 50, 60, 70, 80 years old. So these stands are going to start falling apart. And when they start falling apart, that means more and more light will get into the understory. And it could potentially, if there's seeds available and germination sites available, conifers might move in on their own as these alder lifespans, as these alder stands fade and senesce. Maybe, maybe not. They might go into Himalayan blackberry. They might go into salmonberry. It's hard to really know. But those are some of the considerations I thought I'd bring up because this was a topic that Zach was hoping I'd bring up to you guys, to y'all. So that's how I'm going to end it here. Hopefully this gave you all some information about alder and its role in the ecosystem, and also how alder may or may not fit into your watershed council objectives. And with that, yeah, let's, should we look at the chat, Zach, and see what else we have going on?
Yeah, that sounds great. We have a couple of questions here in the chat. And some of them are, one of them was very recent, so we can bring it up first. The question is, don't large 30 to 40 plus year old red alder put lots of woody debris into the stream when they fall over? Yes,
it does. It does. Let me move back up to here. Alder large wood in headwater streams. Yeah, when you have a lot of alder along these streams, the alder does die and drop a lot of wood into the streams. And we can see that here in this picture as well. There's a fair amount of alder wood down here, and there's two issues with that, though. One is that science and scientific studies have shown that alder wood will decay faster in these creek systems than coniferous wood does. That's just the way biogeochemically the alder wood behaves. So yes, you get these large inputs, but they don't stick around for very long. And so that is why oftentimes people want Douglas fir or cedar or hemlock logs, not alder logs in these creeks. However, I'm not so convinced. I think that as these alder stands fall apart, and see how all these alder are leaning out over the creek, all these alder are going to fall into the creek. I think that these inputs of some woody debris in these creeks is a good thing, obviously. And it might they might last long enough and tide things over until some of the conifers get established and you start getting some conifer woody debris inputs into the streams. So yeah, you're right. The alder does put in wood into the streams, but according to fish biologists, it's not the right kind of wood. Yeah, what else? Okay, Douglas fir doesn't like wet feet as it gets bigger with deeper roots, over 15 to 20 years old. Yeah, okay, that's another good comment. And that's where I think the private forestry accords have some potential to allow Douglas fir to come back. So the current rules are a 20-foot no-touch zone. And that 20-foot no-touch zone right along the creek is the area that's often disturbed when you get these big floods. And that's often where the wet feet occur. And therefore that's where a lot of the alder is. But as you move out away from 20 feet, and now these new private forestry accords, the buffer now becomes, you have a no-touch buffer out to 115 feet. Often that's out of like the stream channel. It's still along the creek, but it's out of the stream channel, kind of up on the a little higher up on the landscape, where you can get establishment and growth of both cedar and Douglas fir. So I think that change in the rules of a 20-foot no-touch zone to a 100-foot no-touch zone. Granted, the first 20 feet stay the same. There's no difference there. It's what's happening from that 20 feet to that 115 feet that I think has some promise with creating large woody debris inputs.
So we have a question from my board chair right now too. Mark, do you wanna ask it?
Sorry, trying to figure out how to unmute, and you might hear a little kid in the background. So that's my daughter. So thanks so much first for the presentation, Andy. It's been really informative and thought-provoking in some way. You know, as a watershed council being tasked with trying to encourage large wood recruitment, we have had projects in the past where we're looking at alder conversion. But more recently, I've been thinking, especially just with some of the higher flow events that we've had in the recent years, that I wonder if we're missing out on some opportunities for, I guess, getting large wooded creeks through landslides and debris flows rather than, just streamside vegetation. And that, in these upper headwater streams that are, most likely in areas that are clear cut, right? If there are ways to encourage still some of these draws to not being cut and getting kind of our large wood from those in the future as well. So curious on your thoughts on that. And also so that's my first question. The second one is, have you seen many studies on how successful alder conversion has been? I know we've done some projects, but it's probably only been around for 10 years, so we won't really know their success rate for another couple decades.
Right. Well, let me answer the second question first. The alder conversion component or the practice that is allowed under, it's alternative, it's alder conversion or alternative practices, things like that. I'm not sure that there's been many studies on it because it's rarely done. The red tape involved is often too much for, well, for timber industry, for sure. For state and federal agencies, they're often just, they want to follow the no touch rule. And for that leaves small non-industrial private landowners as probably the people who have the attention span and the commitment to kind of go through some of these alder conversion alternative plans. And unfortunately, I don't know so much about in Oregon, but when I talk to regulators in Washington, that there's only about, a dozen or so of these alder conversion plans that actually make it through the whole process every year in the entire state of Washington. So it's very small. It's a very hard thing to do, and the success rate of getting them actually implemented is small. So I can really only I can only really talk about what the implementation rates, not so much once they're implemented, what the success rates are. I don't think there's been any studies on that. I did dig into it a little bit. I did do some searching after Zach and I talked about this a bit, just to kind of see what's out there, and I didn't find much. I think these alder conversions are done, but they're done on a case-by-case basis with groups like yourself or with groups like with the private landowner, and therefore don't have the whole cachet of Oregon State University behind them or some well-known professor behind them that actually makes, so the results make the light of day. And that, I think, is a big stumbling block too, because if these watershed councils are doing this work and it's not shared or known about, everyone is starting from scratch. So yeah, I see that as a stumbling block for sure. As far as large woody debris inputs from higher up along the landscape, yeah, I remember about 20 years ago when I went on a tour on Cascade Head, and I was with my former boss who's retired now, and we were with a group of foresters. And when my boss said, not all landslides are bad, the response to the people in the group was like, he just said the most insane thing someone could ever say in their life. The concept of landslides, it's a no-no. Federal, state, private, nobody, I mean, it seems like it's such a bad thing. But when you look at geomorphology of these creeks and the ecology of these creeks, some of the largest inputs of both logs and sediment come from landslides, these local landslides. And local landslides happen all the time, and they will continue to happen all the time. So I don't know if I'm in a position to really say whether I will encourage land practices that I will promote land practices that encourage landslides or not. That's a little tricky of a subject. But you're right, Mark, you're absolutely right that a lot of the inputs from these large woody debris come from farther upslope from these land events, mass slumping events. What I don't know though is if those logs will make it down to the lower reaches of the watershed. Like, will the landslide way up near Vernonia and Mist and the upper Nehalem actually make it down to dairy country down on down by Wheeler? I don't know. I just don't know if the spatial distribution of these land of the large woody debris inputs is important as well.
Thanks, Andy. I appreciate that. I guess you kind of mentioned that, you know, a lot of these riparian dominated alders are going to be close to their end of life cycle. So it is going to be interesting, like what's going to take over afterwards. Like you said, it's going to be a case basis. But I'm just thinking about on, I guess, the projects that we had for alder conversion, it was mainly caging of, you know, plots of conifers with a little bit of alder girdling around those cages, just so there would be some, I guess, greater sunlight input. But I have no idea, you know, did the salmonberry outgrow the conifer? I don't know if anybody's gone back in to check that. So
Right.
it'll be, you know, so that's why I asked about the success rate of anything else like that, because I don't think there's been much funding on post plant monitoring other than maybe, you know, a couple years out.
Right. Yeah, I totally see where you're coming from. I mean, it's such an uphill battle to not only get the funding for a project like this, but then to implement the practice. And by that time, you're either have no more money left or you've moved on to something else. And the post activity, post conversion type of monitoring is often overlooked. I'm not speaking specifically about you guys, the Lower Nehalem Watershed Council, but just in general. Oftentimes, you know, once you do something, you're done and you move on. It's just kind of human nature to move on. It would be nice if there could be some kind of clearinghouse or repository for people to, or agencies or groups like yourself to share information like this. I don't really know if there's a forum where people can share stuff like this.
So
Is that?
I can speak to that a little bit. So restoration projects that are undertaken by watershed councils like us, or by agencies or other groups, they all get added into the Oregon Watershed Restoration Inventory, or they presumably do. So it's called OWRI, OWRI. And that's managed, I believe, by OWEB, the Oregon Watershed Enhancement Board. And it is a repository and a database and even a geospatial representation. They have it all mapped out of where projects have happened and the project type. What often there isn't the funding, you know, I'm going to say this, the funding for is long-term monitoring of a lot of the projects. And part of that is because, for instance, there have been a lot of published studies about building log jams to benefit fish populations. There's been some really great ones, even looking at whether or not juveniles were redistributing to log jams from a like several mile reach of a river, or if there's actually just higher abundance. And those were done over several years to like be able to kind of account for discrepancies in salmon returns, right? So that's neat and that's present. But for some of these other practices or things that are a bit less well studied, there often isn't the funding for the long-term monitoring of the project. And especially here on the North Coast, the watershed councils tend to be very sparsely staffed, right? So I'm the one person for the Lower Nehalem. And so often, you know, there are dozens of great questions that I could be asking and getting good data on with our projects. And there's not the funding or the manpower to implement that often.
Mm-hmm.
Yep. We do have some more questions in the chat here as well. I don't want to forget people. Let's see here.
Yeah, let's see what.
Trying to go back up to where we've okay, here we go. How does red alder spalting occur?
Red alder spalting. Ah, boy. Okay. I'm a forest ecologist. I know my trees when they're round, not when they've been cut into rectangles or squares. I am not really a wood products guy. I do know that spalting in general is the fact that the wood is starting to rot, and the actual spalting are the mycelium of fungus that's growing through and into the wood and around the wood. And the trick is, I think, at least with maple, I'm not so sure about alder, is when you cut it down, that it's spalted enough to have the spalted appearance, but not spalted enough that it's rotten. So it's kind of like spalting is like the early decay kind of the wood. And it's mostly sapwood too, if I'm remembering right, and not so much the heartwood. But that is generally, and then what does the tree need to get injured for the fungus to start growing underneath the bark, or if it just comes with age? I'm not sure about what actually initiates the spalting process. So sorry, Brad. And I guess Brad also has one. Can you estimate the split of conifer trees? I don't fully understand the first question there, but the second question, is there a good way to encourage Western red cedar? That is a topic that federal, state, and private companies have really looked at. Western red cedar has always been a very valuable tree species. It's been a major component of the timber industry for a very long time. But what was happening was that what we were doing is, as a society, we were cutting into the capital, the Pacific Northwest capital of Western red cedar. And like alder, it wasn't ever replaced. And it was never planted back on the landscape because Western red cedar is really hard to, it's a deer and elk really like to eat Western red cedar. So you either have to cage it or you have to fence whole plantations, because if you don't, they will just get browsed to death. In most cases, there's other practices. People have tried planting cedar and spruce in the same planting hole. That way, when the deer tries to nibble the cedar, it gets poked by the spruce. That's been an effort. There's been breeding into Western red cedar into developing more, it's like terpene related products that make the foliage unpalatable to deer and elk. There's a little bit of promise in that, but that's still in its infancy. Essentially, when people want to encourage Western red cedar on the landscape, what they'll do is they will try to plant red cedar like in clear cuts in the nastiest slash pile they can, so the deer and elk can't get in there, and or protect them with tubes. And the tubing, in theory, protects the tree from browse, but it's very expensive. So very few people do it. So there are ways to encourage Western red cedar, but it's not done very often because of all the reasons I just explained.
We, when we plant Western red cedar in our riparian plantings for habitat projects, they tend to get put in a cage that is made of like chicken wire generally, and they're generally caged to about a 3 or a 4 foot height. And what I can say is that often 3 or 4 feet is not high enough to discourage elk from browsing on it when they get that high. And so they spend a lot of time looking pretty shrubby before they finally get a leader up above what the elk are interested in reaching for.
Yeah. Yeah. And then what do you do with all the cages then when the tree gets big enough? And then there's,
They have to be removed. It's kind of a, you know, project by project choice, you know?
Mhm.
You know,
Yeah. The same thing also applies to, this is related, but not exactly, is big leaf maple. My group looked into trying to promote or see what would be needed to establish big leaf maple on the landscape. And the hurdle of overcoming deer and elk browse on big leaf maple basically put the kibosh on that. No one really plants maple. No one really does much with maple. I mean, it's still cut and it's still processed into wood, but that's natural stuff that kind of gets above the browse level. The browsing for both western red cedar and big leaf maple is a hurdle that is often just not overcome.
we plant a lot of both and we cage both. And the big leaf maples, at least their leaders tend to grow faster than we find the cedar do. And so
Yeah.
we get them
Yeah.
above.
Same kind of thing with alder. Sometimes alder will get browsed, but it's generally only 1 or 2 years where it's in that danger zone because it grows so fast.
Yeah.
So if a deer misses it one season, it gets above it. Where cedar grows so slow when it's young, it's in the danger zone for who knows how many decades even.
Decades, plural, definitely.
Yes, right. And maple's kind of in between. Yep. Okay.
We got
See
one
what-
here about beaver alder interactions as an ecosystem service.
Oof. I'm sorry, I don't have the expertise or the knowledge to answer that. I could guess, I can draw some conjectures here. Because beaver, alter the landscape by creating their dams and creating pools above their dam, that will make the water more stagnant. It's not more standing water. And so I would think that the presence of a beaver in a riparian system would be detrimental to the presence of alder. I think if you have beaver there, you're more likely to get ash or cottonwood. I have seen alders chewed down and eaten by beaver. So beaver will eat alder. I'm just going through my head here. What other kind of stuff can I make up regarding beaver alder interactions? I don't know. That's about all I have really on that one. I would think that they wouldn't go well together, but there's probably some stuff I'm missing, some interactions I'm not aware of.
I see a lot of beaver dams that have dead alder stands within them, within the pond.
Yeah. I mean, yeah, one thing I'm trying to run through this really quick in my head, but I'm wondering if the presence or absence of beavers, I mean, it obviously affects the hydrology, like we just said, it creates these pools, but I wonder if it affects the disturbance regime. Like, are beavers in a stream, is the stream more likely to flood and scour out and create new germination habitat for alder? Or would it be the opposite and not create conditions where there isn't bare mineral soil following a flood? I'm not sure. I'm not sure, but those are some of the things that, you know, you can think about when you think about these beaver alder interactions.
The next question we have is, what role does Sitka spruce play in the riparian process and large wood contribution?
Traditionally and historically, I bet Sitka spruce played a very large role. Right along, the Sitka spruce has a very limited geographic range, right? It only really grows next to the salt or really close to the salt. But I think a lot of, but they grew to immense sizes and they grew fast. Sitka spruce still grows to immense sizes and fast. But we cut all those down during the war. So Sitka spruce on the landscape is a lot less than even what it was historically. Historically, I bet it played a very large role, especially in the larger, lower reaches of these watersheds. I would think that if you do a size/age comparison of woody debris across species, because Sitka spruce grows fast but dies young, like a 400-year-old Sitka spruce is an old spruce, where cedar and fir can get to 1,000. I think that if you're looking for a given size of large woody debris input, it'll take you less time with cedar to achieve, not with Sitka spruce to achieve that, than with spruce, and then with Doug fir or cedar. So yeah, I bet historically it played a large role, but there's so little of it left on the landscape in Oregon, at least. I mean, Olympic Peninsula and the Charlotte Islands and, you know, the archipelago of Southeast Alaska, there's still a ton of Sitka spruce up there. But in Oregon, I think that just because of its scarcity on the landscape, it doesn't play a very large role. But it's a species that you could definitely could plant under alder in these riparian systems, but compared to like Douglas fir would be your worst choice because it requires a lot of light. Sitka spruce is your next choice because it can handle some shade, where cedar is probably your best because it can handle a lot of shade. So you got to look at its light requirements as well for its feasibility in these systems. If you were girdling alder or didn't have an overstory, I think you could replant Sitka spruce. And Sitka spruce can handle wet feet too. So I think it's a definite contender to put back into these systems here.
And we do locally have quite a bit. I know that several of the timber companies, when they discovered that Doug fir didn't grow well in the North Coast, started growing a lot more spruce.
Mm-hmm.
So a lot of the plantings have a pretty strong spruce, hemlock, cedar mix around here.
Yeah, and I know up in British Columbia, Sitka spruce is a much more common timber tree than down here. And they've been working on resistance to the weevil as well, trying to come up with spruce resistant weevil. That is going nowhere fast. It's kind of hard to breed resistance to an insect. So I know that generally when I talk to foresters on the North Coast, they'd prefer hemlock over spruce. But yeah, like you're saying, Zach, some people do dabble with spruce, but it really is kind of just dabbling though.
Fair. We have a question about big leaf maple. And it's, how does big leaf maple compare to alder or conifers as a large wood contributor or biodiversity enhancer?
Big leaf maple would be very similar, and I would lump it in with alders when it comes to its role in biodiversity and its role in the ecosystem. I think big leaf maple and alder are a lot more similar in those regards than big leaf maple is to conifers. Big leaf maple, unlike alder, however, big leaf maple will often doesn't form pure stands. Like alder's often in pure stands, where big leaf maple is often scattered as individuals in a across the landscape. So it's different in that regard. And another regard it's very different in is big leaf maple is very shade tolerant, so it will persist in these older communities. So you'll see big leaf maple in old growth forests. You won't see alder in old growth forests. So it's different in that way. But that's what I can say about big leaf maple. I don't think many studies or many people have looked at the role of big leaf maple as a large woody debris contributor. And if they did, I bet it would, I'm just shooting from the hip here, but I bet it has the same type of decay rates that alder has. I bet it would decay fairly quickly and is therefore would be less desirable as large woody debris component compared to conifer.
Oh, someone asked me to link the OWRI website, which I'll toss that in there now. And there's a couple comments about jams coming down the Nehalem River fairly regularly in the big floods, and we will see big wood moving around. And about the alder mill in Toledo that used to be there. I didn't know about that one.
Yeah, there used to be a lot more alder mills. Well, there used to be a lot more mills in general. The companies now, the number of mills have gotten bigger and more automated and can handle a higher capacity. There used to be a lot more what I considered like local mills that would mill wood and different kinds of wood too. Alder mills, maple mills, just smaller mills like that. But that's almost become a specialty, and therefore the number of alder mills in the Pacific Northwest has declined a lot. There are very few alder mills remaining in Oregon and in Washington. In fact, so much so that there's been lawsuits about monopolies and this and that, and leverage and dictating prices because there's only a couple buyers out there. So there were some famous lawsuits 10, 20 years ago about that. And the conditions haven't changed either. Coos Bay used to have a mill. Eugene used to have 3. Philomath had a couple. I think there's still one in Longview, maybe. There's the Garibaldi one. I don't think that's going to last much longer. In Washington, it's kind of the same. There's only a couple. There's one on the whole Olympic Peninsula. There's 2 in the Chehalis Centralia area, and there's 0 now up in the Mount Vernon Bellingham area, the heart of the alder range. So unfortunately, there's not that many mills. But yeah, there used to be a lot more out there. And I don't think they're really cutting. It's a complicated issue, and it has to come with efficiencies and how businesses are structured now with REITs and TIMOs, and with mechanization and robotics and all kinds. It's a very complicated issue about mills and why or why not there are so many or so few. So yeah, well, good. And I'm glad you remember that. It's kind of a shame that they would take these big logs and make chopsticks out of them, but hey, maybe they were great chopsticks. I mean, I know that alder makes great pallet wood because they use it because it doesn't impart any kind of flavor, you know, like if you imagine putting your watermelons on a cedar pallet, you know, you'd end up with a flavor like that. So I know that alder pallets are desirable for certain food industries and stuff. So yeah, I believe it. Chopsticks, same thing. Smoked salmon on the alder plank, you know, same concept there.
Yeah.
So,
Well, I think that's all the questions.
okay. Let me just end by saying that if anybody is interested, Zach, I know he said he recorded this. So
I recorded it. Yep, it'll be up on our YouTube.
And I don't have, I think I neglected to put my contact information. I didn't. I neglected to do that, but Zach has it. So if anybody's interested in questions about alder management or anything like that, or alder ecology, just get my email from Zach, and I'll be more than willing to answer what I can.
Happy to pass it along. I'll put my email in the chat one more time. There you go. And feel free to email me about this or anything else Nehalem watershed related. Always happy to talk to folks. Thank you, Andy, so much. That was a great talk. And
Oh, thank you.
that was just chock full of great information. So I really appreciate it.
Okay, here's my, let me, there's mine. I just put my email in the chat too.
Okay,
in case,
good.
In case people want to get it that way. Yeah, great. I'm glad that you invited me to do this, and I took it as a good opportunity to help kind of spread the word and kind of just get people thinking about alder and how it fits in the North Oregon coast there. And a lot of people have certain opinions about it. Some love it, some hate it. But I figure facts are facts. And once you know the facts and are informed, then you can decide if it fits in with your watershed council objectives, or as a private landowner, your own objectives. So knowledge is power. And so that's what I was hoping to do here, is spread some knowledge.
I really appreciate it. And I can definitely say I am thinking about the systems differently after both our conversation before and this presentation now too. So
Good.
Appreciate
Good.
it.
All right, now let's just cross our fingers and see what this new forest practices accord, forest private accord, what effect that has down. We'll see.
We'll
Time
see.
will tell.
It's going to be interesting. That's for sure.
Yeah. So, all right. Well, thank you so much. And everybody have a great evening and a great weekend.
Thank you, everybody. Have a great evening. And the recording is done now.